friends, welcome to the Tech Protein. So in the last section we have understood the concept of subnet masks. So let us now try to understand why a particular class can be used. Okay, so to start with, let us take an example of IP address that we come across on a daily basis. So consider, let me create a scenario first. So this is my home router. I have consider a desktop. Keyboard and mouse. So this is my home system. So I have connected that to the router using a cable. Consider there is a laptop as well. This laptop connects to the home router using the Wi-Fi signal. Okay, just to show it here, I have another laptop. Wi-Fi doesn't work, so I have Wi-Fi is not working. So what the other option is to connect again back to the home router using a cable. And the next scenario is your mobile phone. So again, this is connected to the home router using Wi-Fi. So friends, this network, if you look at, this is the wired connectivity. So this is wired connectivity. This laptop and this particular mobile phone is connected using wireless connectivity. So this is wired, this one is wireless. Again, this is wired connectivity. And for my mobile, this again becomes wireless. Okay. Now, the next home router, some people also call it as a Wi-Fi router. Okay, some call it as Wi-Fi access point. Okay, some people also call it as a Wi-Fi access point. Okay, now to build the connectivity, now you can see some devices are connected using wired connectivity, some are connected using wireless. Okay, it could also be a situation that your house is pretty big. Okay, and this home router or wireless access point is connected in some corner of your house. So you may need to have another access point at your home. Okay, generally this is again an access point only. This is again an access point. You can say wireless access point, but this is configured as an extender. Okay, so network extender. So this device works in coordination with the primary device. So these two devices are connected to each other. Again, it could be a wired connectivity or it can also be a wireless connectivity. You can set up a bridge connection between these two devices using a wired or wireless, both. So now for connecting it to the internet. The primary home router is connected to the ISP. So consider I have an ISP. So ISP stands for Internet Service Provider. So ISP has been connected. So the link is terminated in your home router. This router is also connected to some other Wi-Fi range extender. There are dedicated extenders also available in the market, but most of the times people use Wi-Fi access points to extend the range. So now here in this case, now to establish communication between all these devices, we need to set up IP address. Okay, so how do we establish connectivity? So this is the physical connectivity. So far we have, so these are all these connections that I have shown depict the physical connectivity. Now, just by connecting these devices to each other doesn't mean that your network is going to perform. So for that, you need to build logical connectivity as well. You also need to build logical connectivity as well. And to build this logical connectivity or logical network, right, or it is also called as logical network connectivity, what you need to have is an IP address assigned to all these devices. So as I said previously, every device on the network needs to have some or the other address. It could be MAC address or IP address, basis which it is going to understand the source and destination and subsequently going to talk to other devices on the network. So now this is a small network. How many devices? Consider you have say 10 users, okay, who have mobile phones with them, right? There are 10 family members. Consider, generally it is usually 4 to 5, but I am taking 10 as an example. So if you look at the total number of users now accessing internet at home, so let us consider this is the range extender number 1, this is your desktop number 2, laptop 1, number 3, laptop 4, then there are 10 mobile users. So if you count, so here there are 10 users. So if you now add up all these numbers, 1 plus 2, 3, 6 plus 4, 10 plus 10, so total number of network devices at your home. Sometime you may also have a device from Alexa, right? Alexa Echo you have, right? For home automation, there are many other home automation products, right? There could be an IP camera installed at your house, right? So there could be a camera, though that camera might also be connected to the home network as well. So consider this is a camera, IP camera I am specifically mentioning here. This is your desktop, this is your Alexa, some music system, okay. I usually do not use them currently. So music system, some device like Echo, Alexa Echo, you have a laptop, right, with Wi-Fi. This is your laptop without Wi-Fi. There could be mobile phones, right, or it could be any other device, okay, that you may have at your house. So friends, looking at this scenario, we came to know that maximum it's going to be say 20 devices that I may need to connect. So consider one, this is again, so 1 2 3, this is 4 5 6 plus 10, consider total 16 devices. Okay, let me correct, I was counting wrongly. So total 16 devices are there at my house. So now friends, you need to decide what type of network you are going to configure, or which class of IP address you need to use while you assign IP addresses to devices in such a small home network. So total number of devices you have is 16. So total number of hosts is 16, right? Now, as discussed in the last session, class A is like this: network host. Class B, network host. Class C, network host, right? So here you see the smallest number of hosts, right? Or if you compare these three classes as compared to class A and class B, class C has lesser number of hosts, right? So now I know that lesser number of hosts, but how many, right? So again, if you look at the bits, so total 8 bits are there, right? So 8 bits, so lowest number can start with 0 0 0 0, starting with 0, and the last value that I can achieve is all ones, right? So it's going to be 255. So total number of hosts that can be accommodated in the class C are between 0 to 255. So if I look at the required number of hosts in my network are 16, so I can easily fit that within this range. Say if I start with value 1, so the last IP that I would be needing would be 16 IP, so it falls within this particular short range, and that is how I come to know that class C is a best network for my home network. Okay, so in the upcoming session, let us discuss more about how or what is the number of networks which are possible in class A, B, C, and the number of hosts available in class A, B, C again, and then what is the total number of hosts that we can be accommodated in class A, class B, and class C. So for now, you need to understand that if you have total number of hosts within the range of 1 to 254, then class C is a better option for such networks. So if you have a total number of systems that are maximum considered 254, then you can definitely use class C IP addressing to assign addresses in that particular network. So I hope with this you have got a clear understanding on what network needs to be used. So we will also be discussing further more details, and we will assign IP addresses to each and every device, and then configure subnet mask, and then understand the concept of gateway and DNS. So I hope with this you have some more understanding on which class of network needs to be used. So I hope this was informative. Thank you for watching, guys.